We're going to talk a little bit about web audio, what it is and what you can do with it. I actually have a similar disclaimer to make as Leo did, which is that I'm not really an expert in this stuff, as you can see. So I've been kind of playing with web audio a lot this year, but I'm really not, a signal processing nerd or a musician or anything like that. So I know a lot more about web than I do about audio. But since I expect that to be the case for most people here, I think we can talk the same language when you're here today. So web audio is all about making noises, making sounds in the browser, in web applications natively. And when we discuss web audio, what we usually mean is the Web Audio API, which is a W3C spec, which they have been working on for several years. It originated in Google, I think, several years ago, and they are still working on it, so it's not final yet. There's a draft every other day, it seems, still, but it is implemented across all the major browsers by now. So this is actually something we can use today, even though there are differences between the browsers and all that usual stuff that happens with new standards. But then the question is, what can we do with this? So, for example, I usually get paid to do business applications, which is, forms and viewing data and things like that. So it's not always obvious what the use cases for audio are, because something tells me my customers would not kind of appreciate me adding explosions to form validation code or elevator music to my applications or things like that. So it's not as universally applicable as something like tables are, of course. But there are many cases still where audio and sound is relevant in applications, and I'll just kind of mention a few of them. The first one that springs to mind every time is games, because when you have a game, you need an immersive game experience. You need sounds or music or both in it. But there are also many other kinds of apps where sounds are relevant. So, for example, anything to do with chatting, video and audio, real-time streaming of sounds benefits from having audio processing capabilities, or broadcasting audio, making internet radio or something like that. Children's applications or other learning applications is also a good use case, because for some reason all the sounds that adults find infuriating, children love to hear, so they love to have like sounds in what they're playing with, so that's a good use case. And then a nice new one is virtual reality apps, so now that we have things like the Oculus and the Google Glass thing, or Google Cardboard thing, and they are becoming available on the web. Sound is of course a very important component of these virtual experiences, and there you need web audio as well. And of course, anything to do with music needs audio processing, whether it's playing back existing music or actually creating music in the browser by the way of doing synthesis or sequencing, or actually performing music with MIDI connected devices. And of course, then you can also combine this with visuals to make some kind of audio-visual art, because we are in the browser here, so we have all these graphics capabilities as well for 2D and 3D graphics, and we can drive both the audio and the visuals from the same JavaScript code, which is a pretty nice thing to do. So those are some use cases, but how do you actually then use this thing? What's included in web audio? So I find a useful metaphor for what's included in that standard to be the setup of an electric guitarist. So you have sort of similar things in there, which are in three key categories really. You have inputs, you do some processing, and then you have some outputs. So when you play an electric guitar, the pickups on that guitar pick up the sound, which is your input to your audio system. Then you have a number of effects and pedals, and the audio signal travels through some graph you have built from those by connecting them together, and each of them may change that audio signal, and you may at runtime change those parameters by stomping on pedals or tweaking knobs and doing different things. And eventually the signal reaches your output, which is your amp, which makes the air vibrate, and then you hear it. So those are the key things you need in pretty much any audio setup, and those are the three things you have also in web audio. So there are many components in that API that fall into one of these three categories. And what I'm going to do now is actually just go through everything that's in that API quickly so you get kind of a rough overview of what are the capabilities of this platform. So as inputs, where does the sound come from? The kind of most straightforward thing you can do is basically just play back a small audio file that you have sitting around, an MP3 file or a WAV file that you have. You can load it onto your page and play it back. That's kind of a straightforward thing to do. You can also tap into audio and video elements, the HTML5 audio and video tags, and get the audio from them and process that. And the nice thing about those is that they support streaming, so it can actually have clips or video and audio of any length, and you can still process it. Then you can actually use the Media Stream API, which gives you access to the device microphone on these devices, but also WebRTC remote streams, so you can get audio from your peers or whoever you're connected to over WebRTC and run that through the web audio graph. Or finally, you can not use any existing sound, but actually make sounds out of thin air by the way of synthesizing them. So you can use oscillators such as sine waves or more complicated sound waves and actually make them right there in the browser, and that's the kind of starting point for doing any kind of audio synthesis. So those are your inputs. Then on the other side, outputs, the most straightforward thing or the usual thing you do is just output it to the kind of default speakers or headphones you have on that device. That's what you usually do. But that's not the only option. You can also output to a media stream to send it to your RTC peers or even broadcast it to many of them. So you can send audio that you are generating live from your browser to somewhere else who's connected to you. Or you can use something called an offline audio context, which lets you output audio to a buffer which you can then replay several times. And you usually do this for performance reasons. If you have a very complicated sound you have to render, you can render it once and then play it back several times. It's a similar thing that you do with canvas. If you have a complicated visual, you draw it once and then you draw that canvas to many places. You can do the same when rendering sounds. So those are the outputs, but really the interesting stuff is what happens here in between. Like the processing that you can do with these sounds en route from the inputs to the outputs. And here you have a lot of stuff you can do. So first of all, you can add gains to control the volume of your audio signal, to set it to some level, or fade it out, or fade it in, or do things like that dynamically. You can add filters, which allow you to set the gain to certain frequencies in the audio, which is a building block for many things from graphic equalizers to synthesizers, sweep effects to wah-wah effects and all kinds of things. It's a very versatile tool, and there are many filters you can do with web audio. You can add delays, which is a basis for things like echo effects and other cases where you need to delay the audio signal for some time. You can do stereo panning to put the sound somewhere between the left and right ears. Or you can do full 3D panning, which allows you to control not just left and right, but also kind of how far the sound source is from you, the volume of that, and which direction it's actually projecting audio to. And this is very interesting for games and VR, because there you often have a visual on the screen, and you may want to kind of sync the sound so that it sounds like it's coming from that source, that visual source. And then you can do reverb to make it sound like you're playing in a cave or a room or a church or whatever, to kind of emulate different physical spaces where the sound reverberates. And you can distort the sound using wave shaping, which is I guess mostly useful for music, if you want to add some overdrive or some kind of other analog distortion effect. And you can compress your dynamics, so if you have a dynamic situation where things may get very loud or very quiet, you can make the loudest sounds automatically a little bit quieter and the quietest louder, so things are a little bit more even. And if all else fails, you can just do arbitrary signal processing in JavaScript by writing some code that takes audio binary data and outputs some other data. So that's what you can do, and there the limit is really not the sky, but the latency you can introduced to your audio signal, because it's JavaScript and it might get slow when you do something complicated. And this is probably where WebAssembly can help a lot at some point. But so here's the buffet you have with web audio. It's kind of surprisingly versatile, and with audio worklets, it's even extensible. So it's kind of nice. And how you actually then use these things is you make something called an audio signal graph. So you take one or more input things and output things and processing things, and you connect them together to form this signal graph, similar to what the guitarist does with the pedals. And then you kind of define where the signal will go between these things. And what then happens though is that the signal graph gets executed on this separate background thread, which is called the audio thread. So you don't actually have the audio signal being processed in the JavaScript thread or the main thread. There's a separate place where it happens, and it's implemented in highly optimized platform-specific C++ code. So it's happening in a place where you don't actually see at all. What we do as developers is define the graph, set up the parameters, tweak the parameters at runtime, make the connections, but then that thing actually processes the audio elsewhere, and it happens asynchronously. And the only kind of time where we actually get to participate in that is when we do these audio worklets, which actually let us put some JavaScript code in that audio thread to be executed. But the rest of the time it's kind of under the surface. And so I mentioned this is all usable right now, and indeed if you look at can I use data, it looks pretty good. We are green everywhere except Internet Explorer, which probably will never get support because it seems like Microsoft is concentrating on Edge now, and it does have support, so that's fine. The thing is though that as the spec is still being worked on, not all the browsers have the same features. Some of them have older features, and some of them have newer features, and it's not always clear what is what. You need to use vendor prefixes somewhere, for example on Safari. And some of the features are not even implemented in any of the browsers yet. So for example, that audio worklet that I just mentioned, it's not something you can use today. So it's still being worked on in the spec, and none of the browsers have shipped it. So there are differences. And also some of these things I mentioned are part of different specs, like the media streams, which are not done in iOS, for example. So in Safari or an iPhone, you cannot access the microphone, for example, because that's in the stream spec, and that's not done by Apple yet. So there are kind of limitations, and there are bugs, of course, as well, which are different on different platforms. So what you usually do when you actually make an audio application is, unless you want to figure all this stuff out by yourself, you use shims and different library abstractions, which lets you kind of ignore the low-level differences between the browsers, kind of like what we used to do with jQuery when the DOM used to suck. You know, we kind of have to use libraries to kind of not have to care about these things. But most of it is there. It is completely usable already. So I wanted to show a few things that you can do in these quick demos. First of all, this one thing I did this summer, I've been working on this, or I worked on this huge article where I basically wrote a web audio tutorial by way of reproducing old experimental music systems from the 60s and 70s in JavaScript. One of them was this Music for Airports system by Brian Eno, which he did in 1975 using huge tape loops, where he basically recorded a sound on 7 different magnetic tape loops and revolved them around the room, so that when he then played those back, the tapes had different durations. He got an infinite ambient music box, which generated kind of infinite variations of music, using just 7 short sound samples. And he did this with tapes, and he published this in a highly influential album. And I did that in JavaScript with set intervals, the same thing. So it's actually a very simple system. So it's basically 7 loops here running, which all are running a different musical note. each of them has a different duration, so these are seconds here. And for each of those loops, I just set an interval with that duration. And whenever it fires, I play that music sample. And here I use the Web Audio API to do that. So I create a buffer source node with Web Audio here. I set the audio buffer to the music sample for that loop. And then I connect it to the graph and start it. And this happens 7 times every 20 seconds or so. And it's really like 15 lines of code or something, this whole thing, which shows kind of how simple things you can do to kind of make something interesting. This is basically generative music. This is making music in JavaScript in just a few lines of code. And there's also a canvas visualization. I'm driving from the same code here because I'm in the browser. I can do graphics as well as sound, so that's kind of nice. So I did that, and then I'll show a couple of other things which you can do if you actually know what you're doing, unlike me. So there's this person called Jake Olba who has done this great little arpeggiator which lets you kind of generate your own Stranger Things type soundtrack. Synth arpeggios. There's this UI here where you can use different chords from different roots and different modulations and kind of test the arpeggios you get from that. And there are different shapes you can select here. And this is not sample-based, so this is synthesized actually right here in Chrome. This is based on the oscillator node of the Web Audio API and a bunch of filters and other things. So it's basically like a modular synthesizer running here in the browser. It's based on a library called Tone.js, which is open source, which lets you do these kinds of things. And it's basically built a UI on top of it, and it's all on CodePen, so you can see the source and everything. It's all there. It's kind of a cool little demo of Web Audio. And then there's something I actually just came across today. So someone has done this integration of Web VR, which is the Oculus kind of thing, the virtual reality API, plus WebGL, plus Web Audio. So you do this kind of telepresence API. So there are some people connected from different physical locations to the same 3D space. And they are talking to each other in real time. They have these avatars rendered with WebGL, and they have audio run through Web Audio, so they're using this spatial panning to kind of make it sound like they are in a space. So here's some of the kind of cutting edge specs coming together, VR, WebGL, audio, to do something interesting. And that's kind of probably a really fun thing to play with when you actually have a Google Cardboard or a proper VR helmet as well. Alright, so then to wrap up, just a few resources I found useful when working with audio and learning it. MDN is usually where I go when I want to figure something out, the Mozilla Developer Network. They have all the audio standard APIs documented well, so when I want to see how something works or what parameters I can use and how I can connect things, that's where I go to see how it works. The spec, which is under construction, they have on GitHub, and it's actually a well-written spec. It's not that long either, so if you're into that sort of thing, you can actually read it and figure out what's going on, or you can dip into certain places there to see how certain transformations are done if you know something about signal processing. And then there's a bunch I've written about Web Audio this summer. There's this huge article I did about this experimental music systems, which you can look at if you're interested in that sort of thing. And there's some other articles I've written and I'm also writing right now. And then if you just want to get kind of keep up with what's happening in Web Audio, get a digest every now and then, there's this newsletter called Web Audio Weekly, which doesn't actually come out every week. It's kind of semi-regular, but still it's kind of good if you just want to get to your inbox, like a little digest of this is what's new with Web Audio right now. And then there's also all sorts of cool demos, so you've probably seen much during the last years as well already, but my favorites are probably the Google Chrome Experiments site, where there's a lot of musical kind of audio-visual demos they've done. And then there's Jake Olbau, who did that arpeggiator demo I just showed. He has a bunch of code pens up to do with generating music and synthesizing music and all kinds of interesting things. So that's what I have today. I hope that kind of gives you an idea of what you can do with web audio, where you might use it, and what's the situation with its implementation at the moment. But I think we have some time for questions as well if you have anything you would like to ask or discuss. Thanks.